Assalamualaikum and hi. My name is Aisyhah Binti Ismal Adlan. My number metric is 271929. Alright, now my group members and I will talk about chapter 14, the last chapter in the Introduction to Occupational Safety and Health, which is noise and vibration hazards. I will start first. So, first thing first, what is sound? What is the definition of sound? Sound is any change in pressure that can be related by the ear. Typically, sound is a change in air pressure. However, it can also be a change in water pressure or any other pressure-sensitive medium. Sound and vibration are very similar. From a physics standpoint, sound is same as vibration but perceived differently. This is because sound has higher frequency perceived auditorily. It means that it can be heard but not felt. Sound typically relates to a sensation that is perceived by the inner ear as hearing. Next, what is noise? What is the definition of noise? Noise is unwanted sound. Consequently, the difference between noise and sound is in the perception of the person who is hearing it. For example, loud rock music may be considered sound by a rock fan, but maybe it considered as noise by a shift worker that trying to have a good sleep. What we think of as sound, the eardrum senses as fluctuations in atmospheric pressure. The eardrum responds to these fluctuations in atmospheric pressure by vibrating. These vibrations are carried to the brain in the form of neural sensations and interpreted as sound. I want to add about hazardous noise. So, what is hazardous noise? It is any sound for which any combination of frequency, intensity, or duration is capable of causing permanent hearing loss in a specific population. Now, I will show you guys a short video of hazardous noise. I hope the video will help you guys to understand better. But don't worry, it's just a short video.
What is hazardous noise?
Have you seen what we'll do to you if you don't speak? Answer me, you fool! What's hazardous noise?
Hazardous noise is defined as any noise louder than 85 decibels that the human ear is exposed to for 8 or more hours. Simply, listening to sounds louder than 85 decibels for long periods of time can cause permanent, lifelong hearing problems.
See, it's just a very short explanation about hazardous noise. So, moving back to this slide, I will continue with the noise exposure effects. For psychological stress related, there are annoyance, irritation, nervousness, inability to concentrate, decreased productivity, and interference without communication. For psychological stress leads to this, there are increased BP, HR, gastrointestinal problem, and sleep disorders. So for the explanation about noise exposure effects, the effect noise has on a worker's stress levels is dependent on many factors, such as the nature of noise, the nature of the job task being performed while exposed to the noise, and the worker themselves, whether if he or she is tired from working. The symptoms of work-related stress include difficulty concentrating, mood swings, poor memory, confusion, changes in sleep pattern, twitchy or nervous behavior, depressive feelings, and changes in normal behavior. For example, eating habits, excessive drinking, or smoking. Therefore, through work-related stress, occupational noise can result in impaired cognitive functions and sleep disturbances, as well as depression. In addition to increased health costs, this can cause safety issues in the workplace. Okay, how the noise moves or disperses in the air. First, sound wave travels in air. It causes the air particles to actually act as a medium between the source and listener. It causes a rarefaction and compression of air particles and force them to carry certain sound energy. Due to that, the sound travels in air and it makes you to intake it and listen to the sound. Okay, as you guys can see, the picture below, the picture of a drum. To illustrate, imagine striking a drum surface with a stick. The drum surface vibrates back and forth. As it moves forward, it pushes the air in contact with the surface. This creates a positive or higher pressure by compressing the air. When the surface moves in the opposite direction, it creates a lower pressure by decompressing the air. Thus, as the drum surface vibrates, it creates alternating regions of higher and lower air pressure. These pressure variations travel through the air as sound wave. Okay, I know this is quite complicated, and I know that through my explanation is not enough for you guys to imagine on how the noise moves. So I also include a short video of explaining of how the noise moves. So please watch.
Imagine you could see what's happening to the air as I hit the skin of the drum. The air is made up of many tiny particles that surround the drum skin. When I hit the drum, the air particles next to the drum skin vibrate and collide with each other. In slow motion, you can see the vibration pass along the line of air particles. It's called a compression wave because the particles are compressed together.
Okay, now is understanding decibels. When we measure noise levels with a sound level meter, we measure the intensity of noise called decibel units. To express levels of sound meaningfully in numbers that are more manageable, a logarithmic scale is used, using 10 as the base rather than a linear one. The unit of measurement used for discussing the level of sound and correspondingly what noise levels are hazardous is decibel. One decibel represents the smallest difference in the level of sound that can be perceived by the human ear. The weakest sound that can be heard by a healthy human ear in a quiet setting is known as the threshold of hearing, which is 1 decibel. The maximum level of sound that can be perceived without expressing any pain is known as the threshold of pain, which is 140 decibel. Okay, now I will continue with hazard levels and risks. The fundamental hazard associated with excessive noise is hearing loss. The exposure to excessive noise levels for an extended period can damage the inner ear so that the ability to hear high-frequency sound is diminished or lost altogether. Additional exposure can increase the damage until even lower frequency sounds cannot be heard. A number of different factors affect the risk of hearing loss associated with exposure to excessive noise. So, the most important of these are, first, intensity of the noise. Second is type of noise, which are wideband, narrowband, or impulse noise. So, what is wideband? Wideband noise is noise that is distributed over a wide range of frequencies. For narrowband, noise is that is confined to a narrow range of frequencies. And then impulse noise. It consists of transient pulses that can occur repetitively or non-repetitively. Next is duration of daily exposure, total duration of exposure, which is number of years, and then age of the individual itself, coexisting hearing disease, nature of an environment in which exposure occurs, distance of the individual from the source of the noise, and the last one is position of the ears relative to the sound waves. Okay, now I will explain about critical noise risk factors. The most critical factors are, first is sound level, second is frequency, then duration and distribution. The unprotected human ear is at risk when exposed to sound level exceeding 150 decibel. Exposure to sound levels below 80 decibel is generally considered safe. Prolonged exposure to noise levels higher than 80 decibel should be minimized through the use of appropriate personal protective devices. To decrease the risk of hearing loss, exposure to noise should be limited to a maximum 8-hour times weighted average of 85 decibel. The following general rules should be applied for dealing with noise in the workplace, like exposure of less than 80 decibel may be considered safe for the purpose of risk assessment. A time weight average of 85 decibel should be considered the maximum limit of continuous exposure over 8-hour days without protection. Okay, so that is all from me. Thank you. I will pass to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name Nurul Mardhiahna binti Kamaruzaman. My number matric 273186. Identifying and assessing hazardous noise conditions. First, noise survey. Noise surveys involve measuring noise level at different locations in the workplace. The devices that are most widely used to measure noise level are sound level meters and dosimeters. Sound level meters provides an immediate reading that present the noise level at a specific instant time. Dosimeters provide a time-weighted average over a period of a time, such as one complete work shift. Can calculate the sounds as a function of the sound level and duration, and describes the result in terms of a dose level, peak level, equivalent sound level, sound exposure level, and weight average. The dosimeter is the most widely used device because it's a measure total exposure. Second, audiometric testing. Audiometric testing measure the hearing threshold of employees. A negative change represents hearing loss within a given frequency range. The initial audiogram establishes a baseline hearing threshold. Then, audiometric testing. Audiometric testing should occur at least annually. So the third, record keeping. It can be used to record test results for individual employees. Such a form should be complete and keep on file to allow for comparisons. It is also important to retain record containing a worker's employment history, all past positions, and those working conditions. Okay, fourth, follow-up. Follow-up is critical. Hearing loss can occur without producing any evidence of psychological damage. Therefore, it is important to follow up. The following will be appropriate follow-up response. So, administrating a retest to verify the hearing loss, changing of improving the type of personal protection used, conducting a new noise survey in the employee's work area to determine whether engineering controls are sufficient, so that testing other employees to determine if the hearing loss is isolated to the one employee in question or if other employees have been affected. Noise control strategies. There are three components of a noise hazard. Noise can be reduced by engineering and administrative controls applied to one or more of these components. The most desirable noise control are those that reduce noise at the source. The second priority is a reduced noise along its path. The last is a noise reduction at the receiver using personal protective devices. Okay, let me explain widely use strategies for the reducing workplace noise at the source, along its path, and at the receiver. Okay, noise can be reduced at its sources by increasing the source, altering the acoustical design at the source, substituting equipment that produce less noise, making alteration or changing the process so that less noisy equipment can be used. Then, noise can be reduced along its path by moving the source further away from receivers and improving the acoustical design of the path so that more sound is absorbed as it travels towards receivers. Lastly, noise can be reduced at the receiver by including the workers using personal protective device and changing job schedule so that exposure time reduces. Engineering controls consist of facility and equipment adjustment other than administrative and personal protection strategies made to reduce the noise level either at the source or within the worker's hearing zone. First, it is maintenance, substitution of machines, substitution of process. Administrative controls. Administrative control are controls that reduce the exposure of employees to noise rather than reducing the noise itself. First, job rotation, shift work, and schedules. Personal protective equipment. First is enclosure, devices that completely encompass the employee's head. Then earplugs, devices that fit into ear canal. Then formable earplug, can be used anyone. They are designed to be formed individually to a person's ears. Use one and then discarded. Then supraoral caps. It's a fit over the external edge of the ear canal and held with a cushion cup that is attached to a headband. Okay, vibration hazard are closely associated with a noise hazard because tools that produce vibration typically also produce excessive level of a noise. The strategies for protecting employees against the noise associated with vibrating tools. So, the type of injuries associated with vibration depend on its sources. So, for example, workers who operate heavy equipment often experience vibration over the whole body. This can lead to problems. This can lead to the problem ranging from motion sickness to spinal injury. So the most common vibration related problem is known as hand-arm vibration and hand-arm vibration syndrome. So environmental conditions and worker habits make it worse to the problem associated with vibration.
Warahmatullahi wabarakatuh. And hi everyone, my name is Norizyanie Najihah Binti Adenan. My metric number is 269675. Okay, vibration hazards. What is vibration? Vibration is a mechanical phenomenon whereby oscillations occur about an equilibrium point. The words vibrations comes Latin, which is vibrationem. Okay, vibration hazards like sound and acoustic phenomenon, but at much lower wavelengths. Another three displacement, velocity, and acceleration. Free vibration. When a mechanical system is set in motion with an initial input and allowed to vibrate freely. For example, pulling a child back on a swing and letting it go, or hitting a tuning fork and letting it ring. The mechanical system vibrates at one or more of its natural frequencies and damps down to motionlessness. Second, forced vibration. When a time-varying disturbance, load displacement, or velocity is applied to a mechanical system. For example, washing machine shaking due to an imbalance, transportation vibration caused by an engine or uneven road, or the vibration of a building during an earthquake. Third, damp vibration. When the energy of a vibrating system is gradually dissipated by friction and other resistances, the vibrations are said to be damped. For example, vehicular suspension damped by the shock absorber. Okay, we can see imaging using a skipping rope. Same principle as wavelength. One complete circle is 1 Hz. Okay, let's see molecular vibrations. Normal mode variations of a molecular in mathematical. Okay, next, systematical stretching, then asymmetrical stretching, scissor tracing, rocking, wedging, and twisting. Mechanical effect. Whole body, segmental. What is whole body? Entire body mass is affected. Sitting in a moving vehicle on a bumpy road. What is segmental? Specific body part is in contact, vibrating medium, use of hand tools such as chainsaw. Second, physiological effect. Increase O2 consumption, breathing, heart rate, brain, vision, motor skills, whole body vibration, and resonance and exchange effect. Okay, we can see here next types of vibrational problems. First, Noice syndrome. What's distortion of capillaries leading to loss of sensation and temperature control. You can see here, so dangerous. Number 2, hand-arm vibration syndrome. Irreversible damage to nervous and blood vessels. Okay, we can see here our hand controlled source or receiver. Okay. First, source, which is machine. Second, receiver, which is person. From source, isolated vibrating surface, damping absorption of vibration E, alter vibrating machine mechanically. And number 2, receiver. Work practice, ergo PPE training, medical monitoring, and rest periods, no smoking, drug use. Third, vibration control strategies. Purchase low vibration tools, limit employee exposure, and change employee work habits. That's all from me and our friends. Thank you for watching. Bye.